Hello, this is Mr. Gilmore with the 4.5 Part 1 Parallel Application Problems. So now that we have our parallel tests and our parallel consequences in play, we're going to be using them then to find the answers to several problems where it involves either lines being parallel or involves some angle relationships. So we're going to see several examples today about how we can use our parallel consequences and our test to actually then find missing angle measures or prove lines to be parallel. Before we get into that, let's review our special angle relationships real quick. Remember that when a transversal cuts through a pair of lines, whether that pair of lines is parallel or not, those relationships still exist. So let's take a look at our diagram. We actually have those four angle relationships, which are alternate interior angles, alternate exterior angles, our consecutive interior, and our corresponding. Let's start with our consecutive interior angles first. Those would be in our diagram, angle 3 and angle 6, that's a pair, and also angle 4 and angle 5, that's a pair. Let's move on to the alternate interior angles. The alternate interior angles then are angles 3 and 5, that's one pair, and angle 4 and angle 6, that's another. And then we have our alternate exterior, which are very similar. We have 2 and 8, and then we have 1 and 7, only we're taking those from the exterior bucket. And then we also have the corresponding angles, which are four pairs. We have 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Now, reminder about your parallel tests. The tests start off this way. If angles are such and such, then the lines are parallel. So if, what about our angles? Well, here are four possibilities. If angles which correspond are equal, then the lines are parallel. If the alternate interior angles are equal, or if the alternate exterior angles are equal, then the lines are parallel. And then we have if consecutive interior angles are supplementary, then the lines are parallel. The converses of this, or the consequences, say that if the lines are parallel, then what can we conclude? If the lines are parallel, then angles which correspond are equal, alternate interior angles are equal, alternate exterior angles are equal, and consecutive interior angles will be supplementary. So we're going to use the parallel tests and the parallel consequences to do several examples today. Let's take a look at our very first example, an angle hunt. So in the angle hunt section on your worksheet, you will be given the assumption that if lines that appear parallel, they are parallel. But you cannot take that assumption outside of that set of problems. They must stay within that section. So the reason for that is we're going to be really nice to our diagrams because I don't want to go through and mark every single segment that appears parallel as parallel. We're just going to give that safe assumption for that section just to be nice to our diagrams. So in an angle hunt, if we're allowed then to assume that lines that appear parallel are parallel, then in the diagram below, I'm dealing with multiple sets of parallel lines, and I'm also dealing with transversals that cut them. In other words, with the transversals that cut them, I have the consequences that I can use to justify why I know what the measures of angles 1 through 5 are. Because I will know corresponding angles are equal, alternate interior, alternate exterior are equal, and I'll know that consecutive interior angles will be supplementary. So let's take a look at our diagram below. We're given that in our diagram, one measure of our angles are given, 60 degrees. We're going to use that to figure out what the missing angle measures are for 1, 2, 3, 4, and 5. We may not have to go in order, and in some cases, we may not even have to use our consequences. We may use past relationships such as vertical angles and linear pairs. Let's take a look at angle 1. Angle 1 I can immediately declare as 60 degrees because it's vertical angle. We know all vertical angles are equal. As angle 2, I can immediately call 120 degrees because all linear pairs are supplementary. So angle 60 and angle 2 must add up to 180. Now let's look at angle 3. There's a couple different ways to get there. Angle 3 is corresponding to angle 1, which means I could declare angle 60 by the corresponding angle's consequence, but also angle 3 is an alternate interior angle to angle 60, which means it would also then be 60 by the alternate interior angle's consequence. Next angle, I'm going to jump down to angle 5. I can call angle 5 120 degrees very quickly because I notice that it's actually corresponding to angle 2, and that means by the CAC, all corresponding angles are equal. And then last but not least, I can call then angle 4 120 because 4 and 5 form an alternate exterior angle pair, which means alternate exterior angles are equal by the EAC, the consequence. Let's do one more angle hunt, but I've got a warning to give you in this one. Let's start looking at our diagram. We are given that there is a set of lines parallel in there. We have the side BC and then the unmarked segment on the interior of BC marked parallel to our side BC. We're given one angle measure. Technically, we're given two angle measures. We have a right angle and we have the 45-degree angle. Let's find the measure of angle 1 first. I notice that angle 1 and angle 45 are going to be an equal pair of corresponding angles because that segment and BC are parallel to each other, and AC is a transversal and is cutting through parallels, which means by the corresponding angle's consequence, I know the measure of angle 1 is 45. I'm also given that AB and BC are equal to each other, which then leads me to think, oh, I've got an isosceles triangle, so the base angles have got to be equal. Well, if one base angle is 45, then angle 2, which is the other base angle, is also 45. Now, here's your warning. You now know the measures of angle 1 and angle 2 in that little triangle formed by A and the unmarked points there. You are not allowed to add the 3 angle measures of a triangle together. We have not proven that. You cannot say that those angles of 1, 2, and 3 add up to 180 degrees. You'll be tempted to do that on the worksheet. You are not allowed to use that. You have enough resources to find the measure of angle 3, so you don't need the triangle angle sum theorem. You don't need to add the 3 angles together to then say they're 180. Because take a look at angle 3 and our right angle B. We know that angle 3 and the right angle B are corresponding, which means they've got to be an equal pair of corresponding angles because those lines are parallel. I could have also used the PLC. Notice that this is one of those cases where a transversal is perpendicular to one parallel line, which means it must also be perpendicular to the other. So I can claim angle 3 is a right angle as well. Let's move on to a parallel hunt now. A parallel hunt means we're going to be given some angle relationships and determining whether or not we have a set of parallel lines. Well, in this diagram here, I've got a quadrilateral ABCD with some given angle measures on the interior. What I notice then about the interior angles is if I take, let's say, segment B and segment D to be our first set of lines to actually analyze, I can then use line A or side C as the transversal, which means if I'm considering these angles that are given, those are pairs of consecutive interior angles. Well, if I want the lines to be parallel, then I need the consecutive interior angles to be supplementary. So let's take a look. Are these pairs of angles here going to be supplementary? They are. 108 and 72 add up to 108 degrees. So I can claim line B and line D, or segment B and segment D, parallel to each other by the consecutive interior angle test. I'm testing to see if lines are parallel. So the consecutive interior angles are supplementary, which then means the lines are parallel. At the same time, I can consider line A and line C to be the lines I'm looking at, which means B and D could be the transversals, and they're also then cutting A and C such that the the consecutive interior angles are in fact supplementary, which means I can claim A and C are also parallel by the same reason. So both of these use the CIAT. And so I will have, in fact, 2 sets of parallel lines. Be very careful on the homework assignment. You may have at least 1 parallel sides, but you may not always have both parallel sides. And you want to check. You may actually have no parallel sides. You've got to make sure you follow the tests that what we've established with our parallel tests. Our last example today comes actually out of a story that Euclid tells. This is actually comes from one of the postulates that Euclid included in his works. So the question that we have at hand below is that do lines A and B intersect? And if they do, what side of the transversal will they meet on? Well, here's the trick to actually determine this. And this is the same thing that Euclid actually arrived to. And it does seem quite obvious. However, a lot of people argued that it wasn't as intuitive as it should have been, and so they argued whether or not it should have been a postulate. But here's the idea. We're going to be, again, analyzing our consecutive interior angles. I am going to add the pair of given consecutive interior angles together. Now, here's what I actually will learn. If I add the pair of consecutive interior angles together and they are equal to 180 degrees, that means they're supplementary. So will the lines meet? No, because we've proven that if the sum of our 2 angles consecutive interior are supplementary, then the lines will actually have to be parallel to each other. But what if they are not equal to 180 degrees? We have 2 possibilities. It could either be less than or it could be greater than. So let's see what happens when we add these 2 angles together, 115 and 60. When we add them together, we get 175 degrees, which is in fact less than 180 degrees. And this is what Euclid's postulate then said, that if the sum of a pair of consecutive interior angles is less than 180, then the lines will intersect on that side, which means these 2 lines, A and B, will intersect on the right. Now think about it, right? The sum of these 2 angles is less than 100 degrees, which means it's sort of as if these 2 lines are not really right, appearing to be straight. They're a little tilted in, which then means eventually down the line, they will in fact intersect. Okay? But if the angles that did add to 180 degrees, then those lines would never intersect. So what we're looking for is that sum. So let's then think about what would happen if these 2 angle measures were greater than 180 degrees, right? So let me adjust this just briefly. Let's change that 60 to a 70. Now let's add these two angles together. When I add them together, I get the sum to be 185 degrees, which is then greater than 180 degrees. But then, so the lines will meet, but which side of the transversal will they meet on now this time? They won't meet on the right. This time they'll meet on the left, and here's why. If the sum on the right-hand side is greater, then the sum on the left-hand side is lesser, which means we have the sum on the left-hand side being less than 100 degrees, so that's the side that they're going to intersect on the left. So be sure to actually take a look at the 4.5 Part 1 assignment. You're going to see some angle hunt. Remember, you cannot use the triangle angle sum theorem. You do not know the three angles add up to 180 degrees. You're going to see also parallel hunting with the last several examples that we've had. If you do have any questions on this assignment, please be sure to email me. With that, be good and do good.